Good morning, everybody, and welcome back to a new episode of MakerBot Chats. My name is Felipe, Creative Director at MakerBot, and I'm really happy to see you guys again here at my living room. As you guys know, Chats is basically our informal platform to have an open conversation with you guys, to talk about materials, the printers, anything that you can do with them, and in this case, actually getting a little bit in depth into one of the specific parts of the process of 3D printing, which is basically creating the files, right? Surface modeling, creating textures, how do you actually print those textures, and I have a few examples here that I will cover. Also, for those of you who might have joined our webinar yesterday on carbon fiber, if you're still here and if you're still interested in hearing some pointers and ideas around how to print and get the best out of printing carbon fiber with the method, do let me know in the comments and I'll answer the questions that were left unanswered yesterday. There were a ton of them. It was a really fun webinar yesterday, just about, how do you actually get the method to print carbon fiber, what are the best practices, what are the issues that I've encountered, what are the things that I've seen with printing carbon fiber, and sort of an overview of like what are the support materials that you can use. You can use breakaway or PVA or SR30. What are the pros and cons of each of them, right? So yeah, if you have any more carbon fiber related questions, do let me know in the comment section, I think on the right. Otherwise, let's get started with today's topic, which is basically creating textures via surface modeling in Rhino and Grasshopper. I'll start by talking a little bit about, and let me jump to my Rhino software here. So talking a little bit about Rhino, right? What is Rhino, why do I use it, and how does it compare to other modeling software? So Rhinoceros, it's a modeling software mainly used for surface modeling. It's fairly old. I think it's been around for at least, 10, perhaps 15 years. I really like it because of the amount of plugins that it has, specifically one that is the one that I'm showing you right here, Grasshopper, that allows you to create what are called parametric surfaces and parametric designs, right? This means that in a similar way to what happens with SolidWorks, right? You're controlling the model via numbers instead of via just curves or discrete parameters. And what that allows you to do is change the numbers instead of changing the geometries. I'll give you an example. In this case, what you're seeing right here in my screen, right? This is basically, I'm taking a surface. Let me hide all of this. But I'm taking that surface and that curve. And what I'm doing is I'm asking the model, first, I want you to split that surface in a number of panels, right? So you see those triangles that are being created. I want to use 20 or 10, 20 by 10, or let's say 10 by 10, and you see how that adjusts automatically my model. This is very similar to what some of you guys might be familiar with on SolidWorks or even in Fusion. The main difference here is that this program, Grasshopper, is a little bit more lightweight when processing the information. So it makes it easier for me to handle large amounts of data. So in this case, I'm just doing a 10 by 10 grid. I could do it 50 by 50, and it'll take some time to load, but you can see like it immediately recreates that grid that I wanted to play with. I'll bring it back to 20 for now. But the point here is that I'm able to make really fast changes because I'm not committing to the geometry just yet. When you make those changes after you've created a fairly complex model in SolidWorks, it's very possible, especially with the amount of data that you're managing here, right? Because each individual panel is going to be now a new surface, that your program might crash. And if you're talking about a larger assembly, if you're talking about a more complex part, it gets really tricky to model these type of surfaces. But it's possible, Fusion, 360, SolidWorks, Rhino here, they all can do it. My preference here is just Rhino. And I don't want to talk too much about the software itself, but rather the application, right? Why would you want to do this type of logic? So I'll run you guys through the logic first, and then some examples on why and where this type of logic is applied, right? So what I'm doing here, carrying on with the example, I'm dividing that surface in 20 by 10 panels. So that's 200 panels, triangular panels here. I've already selected. I won't get too much. If you have some more specific questions, do reach out in the comments, and maybe I can follow up with some of them. what I'm using here is Grasshopper. It's a plugin for Rhino. And for now, what you just need to do is that this is like creating a mathematical model for me to actually subdivide and treat that rectangular surface that's highlighted right here, right? So I'm dividing that surface. Then from that surface, I'm actually taking some of the center points. For example, I'm finding the edges of those little triangles. Let me hide these for a second, because I just want to, so you can see how when I select something in Grasshopper, it becomes green in the Rhino window. So you see like there's the green triangles, then they are red when they are not selected. So the red overlay, it's just something that Grasshopper throws on top of my Rhino interface. And then once I have those panels, the reason why I wanted to create those panels is because I took the center point of each of those panels, right? And I started moving that center point a little bit, right? You can see here in the curve, like let me focus on it. You can see how it's sort of moving up as it goes away and towards the edges. The points are actually floating and disconnecting from the surface. The reason why I did that is because I did a simple extrusion. So I'll show it again here. And that extrusion is actually enabling me to sort of extrude those individual triangles and make them go up as they go further away from that center line. And the center line is actually a curve that I drew on Rhino too. So you can see this curve. As I move the curve, you can see how the program automatically adjusts the height of set triangles. And it allows me to create this fairly complex texture, right? So you can see this is like basically a bunch of pyramids, kind of a diamond shape texture. And similar to what you would see, like let's say on dumbbells or on the grip surface of a bicycle handlebar, right? And here's where it all connects back to product development and why I started with like this a little bit more abstract example. What I'm trying to show you guys here is how do you create textures for some of your 3D printed parts, right? So perhaps you're modeling, as I said, like the bicycle handlebar, and you want to add some grip texture to it, or you're modeling the pedals on that bike, or you're modeling, let's say, kitchen utensils, and you want a section of those utensils to have a texture. This is where this becomes really handy, just to add some extra level of detail. And we won't only focus on how to create those details, but actually how to get them out of the computer and into the 3D printed file, right? So I'll keep moving on. And as you know, one of the files that I have prepared here is, let's say, that example of the bicycle handlebar, right? Let's just imagine that this very simple cylinder, I applied the same logic here. So started with a simple cylinder. As you can see here, let me just double check that this is, oh, it's not refreshing actually. Let me check this again. See why it's not refreshing. Interesting. If it doesn't refresh, then I'll just go directly through the 3D printing process, because for some reason my window capture is not working right now. But let's see. In the meantime, let me know if this, let's see, create new display capture. Let's do display capture instead of, perfect. This should work better. And remove this one. And let's bring this back up. Let's see. Hopefully, so this is you're now actually seeing my whole there. Yeah, this should be better. So now you're seeing my whole screen now. You will be able to see like the back end of the production process. But anyways, I was describing. Sorry about the miss there before. But I was describing how I managed to, I will bring my Grasshopper window again, how I divided this surface. It's actually responsive to that curve that now is highlighted in yellow, right? So as I move the curve is actually changing the way that topography reacts, right? That those pyramids go further away from the surface as they go away from that curve, right? So the pyramids that are really close and the points that are really close to that curve will stay almost flat. As you go further away, you will start to create that creepy element to it. So this example, the idea behind it is basically, I'm going back, so this is what where I realized that you guys were not seeing my screen. I'm sorry about that. But this example is actually, let's see, are you guys? Yeah, I'll just keep doing it. This example, the reason why I brought it up is because I wanted to use that same idea for a bicycle grip, right? So the grip that goes under handlebar. And you can see here, it's a little bit exaggerated, right? But I took the same cylinder, then I subdivided it in a number of elements. In this case, I used the same 20 by 10. I can do a little bit more because I want a little bit more control on that surface. So let's say I'll do 30 by 25, just to come up with a number. And since I don't want it to be so aggressive, I can reduce the amount of offset from that surface. So in this case, it's 10 millimeters. Like the maximum amount of distancing that will happen from the surface to the final element, so to the tallest pyramid that I'm creating. So let's go to 3 here, making it a little bit lighter. That's better. And finally, once I'm ready, I'm happy with the result, I can just go ahead, click bake. That's basically the command to actually create the nerves, actually create the surfaces in Rhino. And now I have my textured cylinder, right? This is meant to be like that diamond texture that we were talking about before. And in the meantime, let me just swap over to my, this is always fun with technology. All right, much better. Coming back to my old and trustworthy webcam here. But okay, back to my window capture. So once I have my textures here done, then I'm ready to play with it a little bit. So I created a few already before the conversation started, and I started sending them to MakerBot Print and printing them out. I actually have one of them printed out, and let me bring that up first. So from Rhino, here we go, much better. Sorry about the delay, but okay. So from what I have in Rhino, flip vertical, here we go. From what I have in Rhino, I can choose to place it in my build plate, where is it? In different ways. Let me show you what that means. So I created a second set of surfaces, what you see here. It's also created in Rhino. What these are is just like these wavy patterns, and it's the same idea, right? So I created a wavy pattern that can be implemented on, let's say that this is meant to be something that is going to be on a kitchen utensil, right? I'm trying to create that grippy texture on a kitchen utensil. Once I'm ready and once I'm happy with the result, I can send that directly to MakerBot Print. Just export my STL file, and here we go. My STL to MakerBot Print. Now I have it in MakerBot Print, and the reason why I exported 2 of these files, and this is where it becomes really important to focus on part orientation, right, is because I wanted to show you guys what happens depending on how you orient the part. We get a lot of questions around, well, what's the maximum layer resolution for Method, how shallow the layers can be, and the answer is right now it's 100 microns. The standard is 200 microns, so every 200 microns it will create a new layer. However, that's always a trick question to answer, because as you hear people talking about like, oh, we can actually do 50 microns, the C height, the C orientation of the part is never going to be as effective as the X and Y plane. Why? And the answer is right here. Let me bring that in. Depending on how you orient those parts, right? Depending on how you actually place those parts in the build plate, you're going to, and this is what this diagram is trying to show, you're going to have quite a different type of light slicing happening. So in this case, I took specifically that file, right? And I sliced it, and as you can see here, the file on the right, so the element on the right, the one that's flat against the surface, by layer 3000, right, that component is practically done, right? It's already um, sorry, it's already finished. That means I only have 3,000 layers of resolution. You know, I could split it out to 100 layers, and then it's 6,000 layers. It doesn't really matter. The point here is that the second element, the one that's oriented vertically and, you know, following the z-axis, is going to have almost 7,000 layers to define that element, right? And the reason why that makes such a big difference is because, as you can imagine, it's not always about the amount of layers, but the density that you might have. So this is like the close-up of it. So when you have the horizontal orientation, you'll start seeing, especially with these surfaces that change a lot in the z-axis as you go up, you will start creating these sort of islands, right? These sort of topographic levels. So that's what you see, let's see here, lower here. And that is going to dramatically diminish your ability to create fine details in the printer. I don't care if you're using a MakerBot printer or a different printer, this is real for any printer, right? The steps that you take on the z-axis only take you so far. Ideally, you would want to actually orient your part, well, the element of the part has the most complexity, the most, that requires the highest level of resolution, against the X and Y axis. Why? Because that actually allows you, or gives you, so much more control over the resolution of the part, right? The two motors that are going to be printing on X and Y, moving the print head in X and Y, are going to add way more resolution than the stepper motor that actually makes your file go up and well, actually down every time that you're changing a layer, right? So it adds a lot of potential and a lot of interesting possibilities on how you can actually capture these very complex surfaces, especially when you're talking about something that really needs to have these more, let's say, dedicated. Let me change this again. Like dedicated complexity. And now for the examples, right? So here I have my part. I'm sorry that the other webcam failed, but you can see, like, had I printed this part. So this part is actually, let me bring back this guy here. This part is actually one of the handlebars that I was showing you, and you can see how the texture really smoothly fades in and out. So as I'm printing, as I'm going away from those first couple layers, I actually start getting those teeth. However, you know, this part was printed vertically, like so. Had I printed it horizontally, then two things would have happened. You know, of course, you can imagine that it's going to be more complex in terms of how much support material I will need, but it's also going to affect how much resolution do I get for every single triangle, right? Because all of a sudden, these triangles, these pyramids that are probably about, not probably, they are 3 millimeters high, the highest ones, right, are just going to have, so 3 millimeters times 200, about 50, is that correct? No, 50 or 5? 50, yeah, 50 layers to actually finish those triangles, which is going to diminish a lot the resolution that I can get when printing the part, right? So as you consider these type of elements, as you consider trying to do surface modeling and adding texture to your elements, also keep in mind that the part orientation is going to change a lot. And this is true, like, for example, I also have a sketch example right here. It's true for any printer, right? The sketch, you might argue, like, it has a little bit of a more basic printing process, but still, if you orient the part properly, you can get really amazing results. Had I printed this part, like, so this part, sorry, this triangular element, right, was printed flat on its side, like so. I could have very well printed it facing forward. Maybe I would have generated more support material. But beyond the amount of support material that I would have generated, what you have to keep in mind is that now I have much less resolution, because I'm actually trying to cover all of these very dramatic changes in a very short, in very few number of steps with the layer count, right? So just by changing the orientation, I'm going to allow myself and add so much more detail to my parts. Same is true here, right? This is one of our carbon fiber parts, and you probably have seen it before. I really like it. It's just a propeller. But again, the orientation is going to change so many things. It's affecting the part strength. It's affecting the actual resolution that you can get, and it's also affecting the time and the amount of support material that you will end up using. So with this, I'm going to start jumping to the questions just to keep, be cognizant of the time. Let me bring back. Well, I think that's a good example, like for the slides. It's getting really warm in here, but what kind of design would you recommend using Rhino for, and what would you use Rhino for, and what would you not use Rhino for? Okay, Rhino. A lot of the engineers out there might say that it's not a real modeling tool. I think that it's more, it's better suited for concept modeling, right? Especially when you're trying to do very complex parts, when you're trying to do very organic parts. So like creating this propeller in SolidWorks, it's possible, but, and actually, there's a lot of companies who actually do that, but it's just going to be simpler to get started with Rhino. I think that for when you're not really sure about what you're trying to do, when you're just like sketching, scribbling around, I think Rhino is a very powerful tool that can help you get your ideas out in CAD and have a first pass at them. Question regarding air quality. Okay, is there an exhaust port on the Method that can be connected to an evacuation system? Yes, there is actually 2 exhaust ports that are constantly pulling air from Method. We are working on a different system right now, but yes, there's actually 2 exhaust ports on the back of the Method that you can connect to an exhaust or ventilation system. What's a good workflow for making small changes to a Rhino model for printing purposes? Yeah, that's a good question. Because Rhino, unlike SolidWorks, in Rhino, once you've committed to a surface, once you've committed to the model, then making changes can be a little bit tricky. So what I usually do is I'll actually copy and paste steps of my model. So I'll, if you see one of my Rhino files, they will have like 10 different steps of the same model as it progresses. So I'm actually sort of time stamping every single element so that if I have to roll it back, I have a reference point. I know that this is like kind of annoying, and it can use up a lot of the space. It basically makes bigger files because you're copying and pasting the same file over and over. But I find that to be the best and easiest way to work with it. What would be a good workflow to combine Rhino's strength in making organic shapes with other parametric modeling software's robustness and precision? So yeah, that's a great question. Actually, I would say, how do you connect Rhino's ease of use for surface modeling with more precise elements? I think that I would go back to that sketching idea, right? If you're sketching on Rhino, once you know what you're trying to do, it's much easier to actually do it and execute it on SolidWorks. And that's the way that I usually do it, right? I'll start on Rhino, I'll create like the main elements of my model, and then once I'm happy with it, once I have some dimensions, I have the better idea of what I'm actually trying to create, then I jump into SolidWorks. Because I feel like SolidWorks can be very demanding. You cannot, well, now you can a little bit sketch in 3D and whatnot, but it can be very demanding, especially at the beginning when you're just getting started with the model. You have to really know what you're trying to do. Whereas Rhino, because you're not always creating solid objects, then it's really much more complacent with the amount of information that it will require from you. Therefore, it's better to just like explore the shapes, play with them a little bit, and get a better feel for your concept. And I'll also bring up let's see. This thing is driving me crazy. Just I'm sorry. Flip vertical, and this guy flip. For some reason, all of my settings in the backend here moved. All right, fair. So I just wanted to keep mentioning it because it's something that I won't get tired of saying. Now is the best time to get the method. I'll keep it there just in case you're interested, but yeah, promo site, because it's really an amazing deal to get this guy for $3,500. So I was saying, like, changes on concept modeling in Grasshopper or in Rhino, and then once you're ready to commit, once you have enough information, jump to SolidWorks, jump to a much more defined platform. And especially ultimately the reason why we all use SolidWorks is because that's kind of a common platform for everybody to use, right? The engineering team, the design team, even the vendors, it's just much easier to communicate in a single file format than to have many of them jumping around. What files is Rhino compatible with? Oof, a lot of them. You can have that. I would say it's one of the most robust platforms, because you can import SolidWorks, step files, OBJs, Collada, sketch files, and the sketch files are actually the ones generated by the Google software. I forgot the name of it. It's an architectural software, but sketch files, even some animated files are compatible with Rhino. So it's really versatile in that matter. You can export and import a ton of files. I think it's over 30 of them. So yeah, how do you simplify a mesh? That's a good question. It depends on the type of mesh. One option is there's a command called mesh reduce in Rhino. There's also a few elements on Grasshopper that allow you to simplify the mesh. However, what you have to keep in mind when simplifying a mesh is that sometimes you might lose some level of fidelity on the mesh, right? If you think about a very organic shape like this one, this is all made with NURBS, right? NURBS are not meshes, they are just like very complex shapes that try to define a fairly blobby, wavy shape, I would say. I know that somebody will actually roast me out there for saying that. But anyways, when you convert this into a mesh, which is what STL files are, you're going to split this surface into many different triangles. The more triangles you have, the more resolution that you will get, right? The smoother the surface you will get. You can think about it based on, like, similar to what happened with video games. If you think about Nintendo 64, it used to have a lot of triangles, so all of the characters were like super raggedy. And as you added more triangles, as the processing power became bigger, then you had more triangles and smoother surfaces. Simplifying a mesh essentially means reducing the amount of triangles and subdivisions, and that will make your files lighter. But at the same time, and sometimes you can see that in the printed files, if you simplify them too much. I don't have a good example for that, but sometimes the actual triangles of the STL mesh will start showing up on your printed file. So you have to be careful with that. But reduced mesh is a good way of doing that. If you still have the original curves, you can actually regenerate that model and make it a little bit simple. What's a polysurface? A polysurface is a surface that's composed of multiple polygons or multiple surfaces in Rhino, right? So in the same way that I was saying, like, once you generate an STL file, the STL is going to be a mesh, and we call a mesh a compendium of triangles that define a shape. A polysurface is going to be a surface that's made out of multiple NURBS surfaces in Rhino, right? You don't use those too much as a concept in other softwares, but that's the idea, right? It's a surface that actually makes up a more complex object. Well, a sum of different surfaces. So in this case, for example, this is a fairly good example. I also generated this one in Grasshopper. There's four surfaces here. Surface 1, let me try to touch it here, surface 1. Surface 2 would be the other side. Surface 3, the first edge, and surface 4, the fourth edge. The polysurface is the whole enclosing volume. How do you reveal that surface? There's a command, reveal the surface, in Rhino 2. You can just type, I think, _ revealed, and that'll allow you to change the parameters on the surface. I think that with that, we're running a little bit low on time. But yeah, let me know if you have any more questions around surface modeling. I think that this was a little bit more of a free-form chat for me, because I really like to share, like, also what I do with Rhino and with other platforms before printing. I want to get more examples printed out. To be honest, I didn't have enough time, so you can see, like, this is a good example to show how robust the quality and the method is, right? How much detail can you get? And also talking about the importance of part orientation, because it's easy to dismiss it as something like, yeah, I'll just print it and that's it. There's big implications, right? From the part strength to the part details, and I could talk for hours about it. But in any case, thank you guys for joining today. If you have more questions, do send them out to felipe@makerbot.com. That's FELIPE@makerbot.com, or hello@makerbot.com, and we'll be more than happy to answer them. Also, if you're happy and you would like to know more about the chats, do go and log into our makerbot.com/chats. That allows us to track better what are some of the subjects that you're interested in, and especially, that's one of the things that I want to hear about the most. Just what else could we be talking about in these sessions? We have a few very interesting sessions coming up in the next couple of weeks, but if you have any suggestions, ideas, or things that we could do better, don't hesitate to send them our way. So again, thank you guys so much for joining, and I'll see you next time. Have a good one.